Development Program, and I now request the keynote speaker, Dr. Robin ma'am, to proceed with the session. Please, ma'am.
Thank you, Saranya ma'am, and warm welcome to all on this final session of the 3-day virtual industry-sponsored program. On the topic we are discussing on predictive healthcare analytics, right? And we were seeing about how are we going to work with text data, what are the types of analytics, and we had the hands-on session. And right, for the past 2 days, how do you take a data set, how do you curate it, how do you work out with missing
Recording in
values,
progress.
if there is, how do you convert your categoricals to integers. And then we moved on into developing a machine learning algorithm, different types of plots with the different visualization techniques, the different packages. And then what are the different metrics? There are many more metrics available, but still, what are the metrics available? We saw up to five or six metrics. All right. And then from today, we started working with the image data set, right? We started working with the image data set and different packages we have seen. What are the image processing packages that's available for Python programming, right? So what are the packages that are available for Python programming? What did we see? Skykit image, yes. And then we saw about SkyPy, and then yeah, Pill Python image library, yeah, PIL is, and then we moved on into OpenCV. Okay, you remember yesterday you could have thought
OpenCV.
Yeah, OpenCV. Yesterday you could have thought, yes, we have done it. Okay, then what is that? We have developed an algorithm. We have removed into training data set and testing data set, and you may think how it could be more useful. Okay, how it could be available. How I'm making the me to this to be a usable product. Okay, so I'm going to share you one. Okay, this is a application developed by an intern. Okay, I take interns in my company, both faculties and students, right? And also those who want to learn on technologies, they learn. Okay, and this one particular student, right? See, when you currently the accurate identification, this is a problem statement. See, when you want to develop, it could be a research contribution or whatever it is, like that you're going to see for it. Okay, and currently the accurate identification of the disease and their level of infections and to find solution is a huge demand right now in India. Okay, what are the technologies? Okay, even when 2021 and 2021 and the COVID was so different, and how are you going to address it, right? So based on these machine learning models, right, based on these machine learning models, you can use innovative algorithms to work on with that. So this is an application we use developed using Streamlit. There are different packages. Once you develop a machine learning algorithm and you find the accuracy is good, you remember I told at least take 3 different data set and try to work out with 5 to 6 algorithms and figure it out which algorithm is best suited for your own application, then you can give it. So once you develop this application, you can give this product to your end customers. It could be hospitals, it could be to doctors. If you're going to develop it for your institution, you're going to predict how much admissions you will get next year, what will be the cutoff predicting of the 5 years of admission to your college, or how are you going to predict how many students will going to pass out in a college or in a university, or you want to find out how many faculties learning the patterns of the faculties, how long the faculties will stay in your institute or they're going to move out, what are the best practices, right? So many things you can predict even in your own institution. So I tell to faculties, you can have some competitions once you learn, okay, and try to develop something that you can make it as a usable product for your own institution. Able to understand? And some colleges are doing it, like giving small grants so that you will keep developing. And once you develop it, okay, once you develop it, and then you can make it as a usable product. So when this application was developed, so here it was on the first beta, first version of it, and you can also have like a drop down menu, male or female, and it will map to male to be 0 and female to be 1, or whatever you have done it as a label encoder, and some values or numerics that you can key in. So a new patient comes to a cardiologist, okay, you get the details, the age of a person. We may not need, because the predicting algorithm, we don't want who's the person, but we want to know if these parameters are there, the person is going to have what kind of disease. You can input the gender, the chest pain type, okay, the blood pressure, resting blood pressure, the cholesterol, the excess induced angina, okay, the ST depression, the ST segment, number of vessels. And when you click predict, if the output is 1, which means the patient has got a disease, 0, the patient has not got a disease. So you may think, why am I developing? I get an accuracy, I get a performance metrics, is the end of it? No. Then you have to make that algorithm to be a web application or a mobile application, give it to the end users, to make them how they are trying to use it. So once you've tested with the data, even without a target, when your application is used by the customers by feeding the data, and they predict it, and you can work it for binary classification or multi-classification or multi-level classification. Able to understand? So this could be another kind of prototype. From a drop down, age, gender, chest pain, and you all give it and click the result, the patient is like to have a heart disease or not. Able to understand? It's not only developing an algorithm, finding the metrics and completing. You need to make, once your algorithm perfectly works with testing data without the target, once you test it, right, you remember X train, Y train, you train the algorithm, fit it on, then predict it, and you get predict and accuracy. You are trying to do it with Y test and the predict one. Once you compare both, and if your algorithm is like 96% or 98%, then you're safe to share. You convert that to be a web application. We are not going to see about that in the session, maybe God willing, future sessions. All right. And once you convert it, then it could be made as a product and it could be used into that. So don't stop your learning of learning algorithm, getting an output of performance metrics, convert it to be a prototype, make it usable, make the version usable. Then you get the alpha version, beta version, and then you submit to the final version of your it. So then, see, as faculties, whatever you do, even a project, if your students are doing along with, make it to be end product. Okay, and make it usable. See, you have got so much of problem definition that resides in your own institution that you work. All right, think of so many problems, right? So many problem definitions, trying to automate things of it. Okay, so if you want any suggestions, you can get connected with me, and maybe at the end after 2:30 I will try to share the vision of my institution, what I'm doing it over here. All right, and this is what is done by the student, right? She used the predicting her disease, and they're predicting the output is yes or no. All right, this is what I would like to say. You are able to understand what we did yesterday? It's not only finding out the performance metrics, you need to turn that algorithm, whatever you have trained, to be a end and usable product. Able to understand? Yes, if you're able to understand, type Y on the chat. Don't worry, there are only 1.5 hours more to complete this session. Kindly cooperate. Yes. How do you convert your application to it? Here I use Streamlit as the application. Yes, thank you, Deepa ma'am. What about others? How many of you are getting connected? Okay. All right. See, when you want to work with some data sets, till this we have completed in the morning session, right? Okay. And also you need to go on for data augmentation. Can any one of you say what is data augmentation? Yes. Can anyone tell what is data augmentation? Yes. Yeah. Say for example, you have a data set. Anybody here work with COVID mask detection? If you load an image, it could be an image or it could be a video. If it is going to detect the particular person has wore the mask properly or not, that can be done using machine learning and deep learning. Anybody has tried? Yes, no? 25 of you are here. So 24, excluding me. Can you give me an answer, please? Yes. So if you want to do it, right? So you cannot take only image that is proper. You need to take an image and even augment it. So you take a proper picture, rotate it, scale it, move to the different sizes of it. Then one picture you can augment to n number of picture. So once your training data are more, then your algorithm, whatever is one part of an image also, it is going to find it out it correctly. Okay, so data augmentation is very, very important. See, your MRI scan looks like that. You can rotate the image for, so if it is one side, the other three sides, or different angles, so you get different augmented images. Whatever is an augmented image that is fed into your algorithm should be sharp enough and fine tuned enough to figure it out where exactly the disease resides. All right, so here I'm giving rows and columns, two attributes, and image. This is the image I had. Okay, image colon 2, because this is how the image shape is. Can you see the image shape? Okay, and I'm going to print only the rows, so only the zeros and ones. I'm taking only the rows and columns, and using the open CV, I'm using another function called cv2 dot get rotation matrix 2D. Okay, this is the function. Okay, get rotation matrix 2D divided by 3 and divided by the rows divided by 3, columns divided by 3, and 90 degrees the angle that I want to rotate, and then comma 1. Okay, then I'm wrap applies an affine transformation to it. So I have the whole image, and M is where I've got the rotation, the coordinates, right, of the center of the coordinates and the rows and columns. And if I show, can you see? The picture has been rotated here. So likewise, from one image, you can augment it and you can take multiple images, and you'll be able to take multiple images. This is very, very important pre-processing step before you try to develop on your healthcare analytics. Able to understand? Can you all try this now? Okay. Rows, comma, columns, image dot shape, only because it's a three-dimensional one. I'm taking only the rows and columns. I'm using this function, the center of the function, to rotate. Okay. So it's little above. If I'm going to make it like 2, divide by 2. Can you see? If you want to shift little above, I'm giving divide by 3. I want you all to try. Already we have loaded the image on the forenoon session. The rows and columns alone I've taken. Okay. Once you have done it, you can tell me that it's done. Are you all doing it? Kindly respond on the chat. If you're doing it, put D on the chat. Yeah. Okay. Yes, you have taken some image. Have you rotated it or are you getting it? The rotated image. Let's be quick. You need to rotate it and you can change by 3 or something like that. We are using two functions, get rotation matrix 2D, and then we are also getting wrap affine for an affine transformation.
Done, ma'am.
Done. Okay. And then, yeah, this is how you'll be able to augment your information. Augment. Now, next thing we are going to go in for a concept called using CV2. It is called as image translation. Okay. There is rotation. Here it is translation. So I'm declaring a variable m np. What is np? Import numpy as np. Okay. That float of the three-dimensional 1 comma 0 comma minus 200, 0 comma 1 comma 200. So this is how I'm making the image and I'm pushing that image before which it was if I run now the image I've reloaded to this image. Can you see the image has been shifted? Like this also we'll be able to augment it. First was rotation. This is changing the space of the image. The more you what do I say, the more you augment your data, more you get into your data. All right, and you can keep changing these coordinates and you can try it out. Okay, now we are moving to this concept is called image translation. Image translation. Others, how many of you are trying it? Okay, you are trying it.
Trying now.
Okay, okay. Others also kindly respond. I'm getting responses only from Deepa ma'am. Yes. Others, how many of you are trying? Or how many of you are listening to it? Or how the image is getting translated? Or able to map it out where you will be able to use it? If you're able to understand how the image has been rotated and thresholding translation has been done. Okay. Can you please explain or you can put that you're able to understand or not? Are able to understand the concept of how are you augmenting it? How are you rotating it using rotation matrix 2D function and using wrap and how are you shifting the images to different corners? Yes, if you're able to understand, type yes on the chat. If not, type no on the chat. Only one response I'm getting from Deepa ma'am. Let me see how many of you are connected to this talk. How many of you are responding back? Able to understand how are you rotating using the function? Second is how are you doing the image translation? Answers on chat, please. Yes. Yes, please. I'm getting response from only one. What about others? Done shifting as well as rotation. Thank you. What about others? So this is a very good alert for the organizers to know how many of you are really connected. Okay, and we have done grayscaling of image. Okay, you can also give comma 0. Okay, the grayscaling and gray image of gray. plt.im show. This is the gray image. Okay, and gray image comma the grayscale. Okay, so you are able to get it. This already we have known. So once you convert an image to be a grayscale image, all right, and then we are going to threshold. What are the different thresholding styling available? See, the original image, the binary thresholding, binary inverted. It's inverted and threshold truncated and threshold to 0 and threshold to 0 inverted. Okay, so these are the different thresholding that you'll be able to do it. Okay, these are the different thresholding that you'll be able to do it. Okay, here I've loaded that image. I have the gray image, and these are the 5 different thresholding techniques. Can you see? Can you see the different thresholding techniques? And again, I'm saying it is not a webinar or seminar, it's a hands-on session. And this functionality, listen carefully. See, I've taken this function.
Yes, ma'am.
Okay, I'm taken this image. Okay, so cv2.im read off. Okay, and I'm making it to be a grayscale, so I'm giving comma 0. And if I'm printing it like gray underscore image comma, what is the color scale that I need? Gray. Okay, I'm getting a gray image. You remember you saw the same image in blue color. You remember during this morning session I showed you. Can you see? This is the original image. This is the original image, and this image I've converted to be of a grayscale image. Okay, once it is done into grayscale, we are going into different types of thresholding. Okay, 120 to 127 to 255. Okay, what is the kind of thresholding? Right, so then I same way as we have tried with the different images, right? The stretching of the image, original size, half size. For that also we use for loop. Same thing, I'm using a for loop because there are 6 images, the original and the 5 thresholded image, and I'm trying to take it out and then put on to the subplots 2 rows, and each row has got 3 images. Say for example, if I want to have 3 images and 2 rows, but the multiplication should be how many ever things that I need to have, and I want to show it as a grayscale. See, if I'm going to run this now, I allow 3 rows and 2 images into it. Can you see?
Yes, ma'am.
Okay, this is the rows and the columns. If I'm going to give 2 rows and 3, and it will be accordingly. Can you all try? Can you all try? The thresholding of the image, the thresholding of images. Let's quickly try. If you want, you can make the image. Take whatever image you have, give it comma 0, cv2.im read.
Going
Convert.
to try.
Yeah, please do try. Listen, audience, participants, professors, it's a hands-on session. I strongly encourage you all to try. I'm getting response only from one participant, not from all. I know some of you are silently working without responses. Kindly do give a response, please. How many of you are trying it? Other than Deepa ma'am, I know Deepa ma'am will give me an answer. What about others? How many of you are trying it? Hello? How many of you are listening to? Type L on the chat. Yeah, you're working. Thank you, Cornelius, sir. It depends on the internet speed. Working. Thank you, Shanti ma'am. Once you give a response, it's strong and it's encouraging for us.
Done, ma'am.
Done. Others, have you done? So Cornelius sir and Shanti ma'am. Yeah, you can just copy the codings. Okay. You have to read the image using cv2.im read. Then give the path that you have loaded it from your Google Drive. All right. And then comma 0, it's a grayscale image. Okay. And you're plotting it. And if I want to show it as gray image, comma gray. The color format of it. Yes. Three of you have responded out of 24. I don't know how many of you are silently working. Okay. Now we are going into the thresholding. Okay. When you see it's a CV2
And ma'am.
thresholding. Okay. The thresholding. Well, these are the different functions of thresholding. Basically 5 functions that comes along with. Be always or use, if you want to use OpenCV, docs.opencv. Can you see here the different thresholding? Okay. And here the same threshold is applied for every pixel. The same threshold. If it is smaller than the threshold, it is set to 0. Okay. And what is the, and see, this is what you could have thought, why am I changing my image to be a grayscale image? If anybody would have asked the question, why ma'am, you can use a direct image, why are you converting the image and converting into a grayscale before you're doing a thresholding? This could be one of your questions. See onto the screen. I hope you're able to see my screen, right? What I'm highlighting. The first argument is a source image, which should be a grayscale. So if you are going to do a thresholding of an image, and the first argument should be mandatorily a grayscale image. Is it clear? If you are going to use the thresholding using OpenCV, all right, the first argument should be a grayscale image. You could take a color image, you convert to be a grayscale, that's what we have printed it, and then only we are going into the thresholding. Able to understand? And the second argument is a threshold value. The second argument, what is the threshold value that is used to classify a pixel? The third argument is a maximum value assigned to a threshold, assigned to a pixel value exceeding the threshold. So second argument is the threshold. Okay. Third argument, what is the, this is the threshold, 127 is the threshold. So out of it, what is the maximum threshold? I told you between 0 to 255, right? So the threshold value is, to classify the threshold value is 127 I've taken. So what is the maximum value? If it is 127 above, it will be setting up to 255. If it is less, it is make it to be 0. Okay. And the fourth parameter is the, what is the type of the function? So when you see, the first is should be a grayscale image, the threshold value, the maximum value. Okay. And then what is the type of thresholding? So here we have 5 types of thresholding. Okay. CV2, binary. Okay. Binary inverter, trunk, 2 0 and 2 plot. See, so if you take an original image, are you able to see my screen where I have a boxes of blacks and white of image? Can one of you unmute and see?
Yes, ma'am.
Yeah. Okay. So
Yes,
original
ma'am.
image, this is the binary. Can you see when it is dark, it is becoming black, and if it is a little color, it is becoming white, and this is the inverted of it, trunking of it, and 2 0 2 0 inverter. Okay, 2 0 and 2 0 inverter. Can you see this original image? Okay, global thresholding. There are different means of other thresholding. We are not going into this. Okay, you can try it after which, but the basic things we are going. CV2.binary. Okay, and what happens in CV2.binary? What are the different functionalities? See, this is the threshold value. These are types of thresholding. What happens there? Okay, threshold. There are different values on a grayscale. I'm thresholding black and 1. Threshold binary. Inverting 1s to 0, 0 to 1s. Then I'm truncating. It's not very dark, right? It's not black or white. I'm truncating it. Can you see the wave getting truncated? And I'm making the truncated to 0. And then the threshold to 0. Threshold to 0 inverted and threshold to 0. Okay, so these are the different thresholding. Able to understand about the thresholding? What do we do at least in it? Yes?
Yes, ma'am.
Okay. We are not going into the adaptive threshold. We are just going into the 5 thresholds that CV2 provides. Okay. And we are going to do the thresholding of an image. And then we are using the display. What is the names that I want to display? First is the original image I want to plot. Okay. That I have it in gray image. Okay. And next is my threshold binary. Then one threshold binary inverted. And then threshold truncated. It's not directly zeros on 1. It is a different bit of color. It's not directly zeros and ones, right? Truncated, then truncated, threshold to 0 and threshold to 0 inverted. Can you try this now? You remember in this variable you have the gray image. In this variable you have the gray image. I'll give you 5 minutes of time because the coding is little huge. I want you all to type it out, then only you'll try to find if you get an error or not. Any doubts? I was asking, only 4 of them answer. How many of you are listening to this talk, or you are doing this talk, or trying to do that? Can you all type P who are listening, or you are doing both? I'm giving an option. Try to type P on the chat, capital P. Let me see how many of you are responding on the chat, capital P. Yeah, trying. Okay. Only I got response from Deepa ma'am trying. What about others? Are you all trying? Try thresholding. Yes. I hope you're all trying. You need to give the first parameter as a gray image. Then what's the threshold value, the maximum, and then the different types of thresholding. and we are displaying it. I'm giving a list for the names and the image values, and it returns two values, and the threshold image. Okay. Is Karthik answer? You got doubts? Any doubts? You can, otherwise you can mute. Okay, I hope you're all trying. Yes, by 2:40, yeah, we'll have a live quiz. Okay, 50 minutes from now, and out of which during this,
Looking, ma'am.
yeah, keep doing it. Once you're done, you can give it on the chat as done. Listen carefully, participants. It's a hands-on session. If you keep trying it only, you'll be able to get done. If you're getting errors, you can ask me. Please don't be like connecting and then going. It's not the certificate that is going to speak how much content you're able to work on with that. That is more important. I always think when I get calls for faculty training and students training, I always give importance to faculty training. The reason behind, through you, so many students in your lifetime, they get trained. Yes. Any doubts for others those are working out? Mm-hmm. Once you have done, you can let me know. And it returns two parameters. Okay, that's what we give, two parameters. This method returns two. The first is the threshold, and the second one is the thresholded image. Okay, RAT is the threshold, and the second one is the thresholded image. Yeah, Suruchi ma'am, you're also working. Thank you. Nice to hear. Because it's a talk means I can give a talk, I can explain it and then go. Because it's hands-on, once you really keen with your hands, the stop, the underscore, this non-user defined. If you're doing it only, you'll be able to understand things for better out of it. Yes, please. Once you have done, you can tell me the 5 types of thresholding. This CB2.threshold functionality returns 2 values. That's what we are giving here, 2 values. One is the threshold value, and then it's the thresholded
Done,
image.
ma'am.
Threshold, thank you, Deepam. Threshold and the thresholded image. Okay, able to understand? Okay, original image, binary, threshold inverted, threshold truncated, threshold to 0 inverted. So these are some pre-processing technique that we need to have it. Now we are going into an algorithm called as canny edge algorithm. Okay, if you want to find an edges, there is an algorithm in image that is called as canny edge. Okay, so in CV2, okay, before we move on with that, this is the algorithm. You think like it's just an function that you're going to use. Okay, there are different things. One is a edge detection and the next one is a contour detection. When you take edge detection, it means you take an image, the entire edges of an image is taken. But when you take contour detection, is different. Edge detection, contour, it is only for closed objects that is present inside the image. Okay, contour is the closed objects that is present. Say, for example, if you want to detect a tumor, you go on for contour. It's a closed object onto the image, it finds it out. But edge detection, it takes the entire edge. And this is from the canny edge. Okay, you think it's just one algorithm. It's one of the most popular edge detection algorithm. Okay, so it was developed by John F. Canny. So what are the stages it goes through it? See, you would have thought why ma'am told about thresholding, translation, filtering, noise reduction. Okay, so this, when you want to develop, like, this is a predefined algorithm. If you are a research scholar, you cannot use a predefined algorithm and get your work. So, for example, if you're professors, you want to work on image processing and publish papers on journals, or you want to have your own pattern, something that's workable, right, with a good functionality, you cannot use what is existent. All right, you cannot use what is existent. So this is one of the very popular canny edge algorithm. Okay, first it reduces the noise. Okay, and what is that it here it uses? It uses the Gaussian filter. You remember how many different types of filters we have seen, right? Median filter, Sobel filter, Laplacian filter, even Gaussian filter we have seen, right? You can, when in your proposed algorithm, you can try to contribute a new filtering algorithm, filtering mechanism, wherein the noise of your data gets reduced. Able to understand? Able to understand? Where the noise in your data gets reduced. Here in this candidate, she has used Gaussian filter. Now we've got so many filters. You can use the different filters. Then he finding the intensity gradient. He does a smoothing. Smoothing is then filtered with Sobel kernel. Okay, here he has done the smoothing. First he finds the edge gradient and then he goes in for the smoothing. Okay, this gradient direction is always perpendicular to the edges, rounded to 1 to 4 angles on the vertical, horizontal, and the image intensity gradient of the image. And then the next fourth step, what he does, he makes the non-maximum suppressions. Okay, so he does the full scan of the image. Okay, removes what are unwanted pixels which may not constitute the edges. Okay, and then for every pixel he finds the local maxima, minima, and then he finds this is an edge of it. Can you find the gradient? Okay, the maximum gradient intensity on 4 directions, and then here he finds where is this local maximum in the region. Can you find it out here? And then he points and and then he goes into the next process is called as, yeah, in your binary image it's with thin edges. It goes as for a thresholding. Now we have done a thresholding. Here he uses hysteresis thresholding. Have you all tried these concepts from the morning? Yes, noise removal, thresholding, finding the edges, local and maximum minima. Yes, so as you, that is what I tried you to give the concepts here and then you will be able to integrate it for your new proposals, right? So all the edges are very really, and then it finds which has the minimal value, the maximum value. Two thresholds are classified, and then it finds the edges of it, and then it finds the edges of it. See, this could be the original image, and it finds the edges of it. Able to understand the concept? So 5-step happens, but here you don't see it is all embedded into this function called cv.canny. cv2, here they've imported cv2 as cv. You can also use cv2.canny. The image and the edges could be plotted. Okay, so how many steps are being done in canny edge algorithm? The first, the noise reduction, finding the intensity, non-maximum suppression, and hysteresis thresholding. Like that, what are the concepts you have learned? You can able to try to figure it out and try to put it onto it, and then propose your own new algorithm. All right, now I will share with you an image, okay, which is a brain tumor image. Can you see this image? It has got a tumor in it. This is a brain MRI image which has got a tumor in it. For this, we are going to run a canny edge and try to find the edges of it. Okay, let me share it. This image. Let me share this image on the Zoom chat. You'll be able to get it. Why wonder? Have you all got the image? If you've got the image, can you type yes? Have you got the image? Okay, see, here I'm using already we have imported first two. I'm reading the image y1.jpg. You have to give the path if you're going to load it onto the Colab. Okay, cb2.image. Okay, 100, 200 as a size. This is the image file, right? This is about cv2. Okay, cv or cv2, whatever you call it. Okay, it takes the image, the input image, the input are the image, the thresholds. Okay, what are the thresholds that you want to have? Two threshold. The first threshold of the hysteresis procedure, the maximum and the minimum value. I told you about the hysteresis threshold, right? The maximum and L2 gradient, it's a flag indicating for more accuracy. L2 gradient, it is for more accuracy. Okay, L2 gradient, it is for more accuracy. And here I'm giving L2 gradient is equal to true. Okay, the third parameter. So 100, 200, the minimum, the maximum threshold, right? Can you see the minimum, the maximum threshold, the image, and I'm making, generally it is false, I'm making it to be true. Okay, I'm making it to be true, and the size of the edges. So when you come here, so image, threshold, comma 3, okay, and gradient equal to 2. I'm just plotting the figure, and then the title is brain canny. I'm saving it as PNG, and the CMAP. Can you find the entire image? If I could, this is the edges it is showing. If I run the original image and show what is the value of the original image, IMG. Okay, say for example, I'm going to use IMG. Can you see? This is the original image. Okay, this is the original image which has a tumor in it, the brain tumor. And using canny edge, you are able to get, it's not contour, it's not contour, it's an entire image, and the edge detection is different from contour detection. Edge detection, it takes the entire edges of it. When contour, only that contour will be taken. I will show a demonstration. We don't have time to explain and run the code. For contour, I'll explain to it. Okay, now we can try the edge detection. You can also, if you don't want it, we can remove this, and only this you can use. You read the image. I hope you all got that image, and load the image and try to use canny edge detection algorithm. You think that you're using only one function inside, which 4 to 5 steps have been running inside. It is a multi-stage algorithm. At least this I want everybody to try it out. Take an image. I've loaded this image. I've shared it to you. Okay. I will also share it onto that Google Classroom. Feedback form, you'll get it. Now try to work on with the some of you have shared the notes. The notes I didn't ask. The notebook is the Python notebook that you have tried working it out. Some of you have shared the notes. Some of you have shared this, not this. The Python notebook itself, you can share it. See how this ma'am has shared. Suruchi ma'am has shared. This is not that is expected. See this file, the file that you're working, right? That you need to share it, not your notes. See, she has shared it correctly. Now coming on to this, I hope you're all doing it. Now you can share it, ma'am. If you're not getting any errors, then it's fine. Okay. Keep trying this. Once you've done, you can tell me you've done. I've shared that y1.jpg also into the Zoom chat. Are you all trying it? And post which demonstration will be shown to you.
Yes, ma'am.
Have you got the edges? Contour, I'll just show the demonstration. We don't have time to implement it. Okay. Have you got it?
Got an error, ma'am.
What was the
Trying to rectify.
Okay. Others, how many of you are trying it? Can you show the code before opening the image? This is already we have opened, no ma'am. Import cv2. This is what is the first thing. cv2.im on y. Don't give y1.image. Here you have to go where you have loaded your. Where have you loaded your data on your drive, and you need to copy the path of it. And wherein you need to copy the path. That I've used Anaconda to show the demonstration. I hope I may have it on my drive also. So many notebooks here and there on different mails. Yeah, see, I have Y1. I can copy. You're able to see my screen? Copy the path. Yeah, see, here you can use this also. This is the image. After can you see? I have not given in. Try this. It should be the y1.jpg should be loaded onto your Google Drive. You have to give according to your path, you have to copy and give the path here.
Done, ma'am. But done with another image, ma'am.
Okay, that's okay. Any other image. See, you need to know how to work out with the functionality. Any image is fine.
Yes.
Because each one of your requirements will be different. Okay. And Suruchi ma'am, you can make a note of it. You can try it out. y1.image and im.show of image. You're showing it, and this is a very simple algorithm. But it looks like only cb2.canny. Okay. Your image and the threshold and the maximum one, and you can show the edges. Every edge of the image will be taken. And also in image you can go in for segmentation. You want to segment a particular part of it. Okay. Yeah, done. Thank you, ma'am. Thank you. So if I want to put in a grayscale, you'll be able to see it even more clearly. Here I'm just printing the edges one. If I'm printing with an color image, can you see? You'll be able to see it even more clearly. Okay. And the next we are not going to try, but I will show you what it does. Okay. How are we going to work on with that? This is called a segmentation. Okay. This is called a segmentation, where I told you, right, there's a difference between edge detection and contour detection. So what is the difference between edge detection and contour detection? Can one of you say? Edge detection takes the entire edge, takes the image, the entire image, the total edges of the image. But what contour detection will take? It will take only the closed objects edges, not the entire edges, only onto the image where we have a closed objects, right? So the edge detection is different from just a minute. Edge detection is different from contour detection. Okay, edge detection is different from contour. Okay, so okay, see, I'll just show you that is how are we going to work on with contours. Okay, how are we going to work on with contours? I have this image. Okay, I have this image. Okay, you can listen now. From now on, you'll not be working on with that. You can just listen to the different concepts that we are going to, and that I'm going to share it with you. Okay, we have taken this image, but listen carefully. Okay, I've taken this image. I'm plotting this image. First, we have done what we have done. We have done edge detection using canny edge algorithm. Okay, then I'm converting this image, okay, bgr image, to a red green blue channel, and then that red green blue channel I'm converting it to be a grayscale. So gray one contains my grayscale of my image. Okay, the grayscale of my image. And then I'm doing the first step. I took the image, converted to different channels, and at last I got a gray channel. In that gray image, I'm doing a binary threshold. You remember we learned 5 types of threshold. Here I'm using cb2.threshold inverter. I'm showing them. It's the same image. Okay. Now you can find it out how when you write algorithms, the components, whatever we have learned, the phone-in session is able to apply it over here. I'm doing a thresholding of it. Okay, I'm doing a binary threshold binary inverter. So that is available in binary one. There's a binary thresholded image. Okay, and then there is another function called find contours. So what did I say? What does contour does? What does contour does? It finds edges of closed images that is available in your image. Okay, edge detection, the entire image is edges, but contour only closed objects that is available in your image data set. Okay, I'm going to give the binary inverted thresholded image, then cv2, right, the different parameters, what I want to do it from a thresholded image. Finding contours also returns to functionality. See, you can find it out. What are the parameters of find contours? Okay, Okay, this is the function, find contours. Okay, the curve joining all the continuous points along the boundary, and more importantly, that should have the same color intensity, have the same color or same intensity. Then only it is used generally for object detection and recognition. You want to detect in healthcare analytics a particular space it has been infected. It could be a skin cancer, or it could be a chest x-ray, or whether whatever is the image, MRI or CT or whatever images that you're going to do, you want to analyze a tool for shape analysis. See, the ECG is, you want to do a shape analysis, then you need to go in for contour detection. Okay, and object detection, and then this functionality it is used is called find contours. Before finding contours, you can apply thresholding or canage. Okay, and then here they're taking a image read, converting it to grayscale, thresholding the image, and doing a find contours. Okay, and find contours, draw all contours in an image. Okay, and then says only the fourth contour, that's -1 means all contours, fourth contour only 3. Okay, so this is what, it's an image, and how do you get it? Okay, so when you see the CV dot find contours function, the first is the source image. Okay, the second is the retrieved image. Okay, how many parameters you have it in find contours, right? The source image, the contour retrieval mode, and third is contour approximation method. So that is what retrieval, CV, retrieve, and the approximation method, chain approximation simple. Okay, it uses, whenever the image is taken into it, what kind of data type is the image? If I take a JPEG and load it, when I type the data form, what is the type of data when I load an image into this? Using CB2 or sklearn, can one of you say what is the data type? It is, answer please. I take this image and I load it, right? If I'm going to find type of image 1, what is the type of image 1? When I load it, it is a JPEG, but when I type it, what is the type? It is a NumPy array. NumPy array. Able to understand? So that is what here it is taken as a NumPy array. The image, okay, the thresholded image, I'm going to send it. Okay, and then first you need to convert it to grayscale, thresholded, and what is the retrieval mode, and what is the contour approximation mode. So I'm doing both here. Not this one. Okay, I'm drawing the contour. So you're able to understand what are the functionalities I'm giving. It returns 2. This function returns 2 methods. This function returns the contours and the hierarchy. Contours, it's a list of contours in an image, okay, which is a NumPy array, and it calls the boundaries, and it calls the boundaries of them. So when I come here, all right, when I come here and I use chain approximation none or whatever it is, and you have to give a retrieval mode and the approximation mode. So once I'm giving my retrieval mode, retrieve and simple, and I want to draw the contours. Find contours is one step, and then I'm drawing my contours, contour image. This contours one contains my contour. I'm going to draw the contours onto the image one. -1 means all the contours from 0 to 55, 0, 2. Can you see all the contours on it? Okay, and if I'm going to see for a closed image, right? Okay, so this is thumbs up and thumbs down image. Okay, same thing, I'm converting it to be a grayscale image. Okay, this is the original image, this is a grayscale, and showing it as a grayscale. I'm doing the thresholding, I'm showing the thresholded image, I'm finding the contours. Okay, after the thresholding binary inverted, I'm showing the contours, drawing the contours. Can you see? For the closed image, not all the image, only for the closed object, can you see the contour? Yes, no? Thumbs up and thumbs down?
Yes, ma'am.
This is how you'll be able to find contours. Image, able to understand. Okay, now let's move on to something called a segmentation. Okay, it is one of the, as we know, the renowned algorithm is contour for canny edge algorithm. We want to segment something, right? We have an algorithm called as watershed algorithm. We are not going to work, just I'll tell you how it works. Okay, I'm importing the necessary packages CB2, matplotlib, and inline. I'm reading the original image and I'm converting into V as a the original image. I'm posting it out and I'm converting the original image to be grayscale because it is MRI, it looks like a grayscale image. Okay. And then you remember the morning we saw about different filtering, median filtering. You remember, anyone remembers it? Sobel filtering, and I'm using median blur. Okay. Yeah, median blur I'm using. Can you see the image is blurred? And I'm using a median filter to remove the salt and pepper noise. To remove the salt, sorry, to remove the noise only, we use different kinds of filters. All right. Okay, to remove the noise, maybe it's Gaussian, Laplacian, Sobel filter, Roberts filter. Okay. And I'm using a median blur and the median filtered image. Okay. And then I go on for see, there are different, that image I'm applying to be the grayscale image. I'm applying a Gaussian blur. I'm then going for a Laplacian operator. Okay, after blurring and going for a Laplacian operator and I'm able to find it out. So this is how I get it for a Laplacian output. Then if I same thing, if I use it for Sobel filter, can you see the difference of this on Sobel filter? All right. And then I'm doing the thresholding of my image. You remember we saw like 5 thresholding, right? So the image, what is the threshold, what is the maximum value, and the threshold binary. I'm printing the grayscale. And then what I'm going to do, I'm going to determine what are the foregrounds, what are the backgrounds. Okay. So using a morphology EX function, okay, I'm using finding out what are the foregrounds, what are the sure foregrounds. Then I go in for morphing, okay, morphology, and then I dilate it. So dilating, you make one image, you make it little more bigger, so you know that's a determined area. Okay, after I use my dilation, I know dilate function, I'll be able to know what is my sure background. Okay, these are my sure background, and then and I get my sure background after thresholding. Okay, and what is the distance between the sure background and the, because I've dilated, the space of the edges would have become maximized. Okay, and then I'm using again thresholding with the distance and I'm getting the sure background, sorry, foreground. Then what do? I'm going to subtract my sure background and my sure foreground. This is my sure foreground. See, this is my sure background. See, after dilation, I get my sure background. What is my background alone? And to get my sure foreground, I'm getting foreground area. I'm getting my distance using distance transform and threshold function. I'm getting my sure foreground. So, and both I'm going to subtract it. And I'm going into this function called find contours, where I have my sure foreground. Okay, and you know, find contours gives 2 parameters, and I'm having my markers. And then if I found out, can you see the closed edge of this being segmented? Are able to find the difference between contour detection and edge detection. Contour only the closed objects, but in canny you are able to get everything. Here we take the sure foreground, sure background, then we subtract both and we get the image. This is the original image. If I want to emboss it onto the image, can you see? Are able to find the contours onto the image. Here can you see here and also here? Yes.
Yes, ma'am.
Okay, this is how you need to work it on with your health analytics. You can take like hundreds and thousands of data or lakhs of data, like Brad's is one data set, all right, where they have got huge data sets, right? You can load it on and then figure it out. Okay. And this is canny edge. Can you find the difference between canny edge and find contours function? Yes. Okay. Okay. Yeah, thank you, Suruchima. Okay, the next thing that we are going to go, I don't have time. If I have time, I can show how for an image that we have worked it on. And also, you can also, if you want to segment it, okay, or if there are so many XML files. har cascade is a function. Okay, har cascade is a package. Okay, where it has given so many algorithms to figure out the faces, the nose. Okay, also, right, so many things. Okay, for face detection. Okay, say for example, I'm going to an edge features, the line features, the four rectangle features. So it will be able to find from an image whether face is available or not. Okay, okay, if I'm going to give this and if I'm going to click on try it out. Okay, can you see? It is able to detect the eyes and the face. Able to see on my image? Able to see?
Yes, ma'am.
Yeah. So like that, you can also segment it and find it out using HAAR cascade classifier. So in cascade classifier, you have got for face classifiers. Okay, for eyes, for nose. Here we have worked it for face and eyes. Face and eyes. Okay, see, I've taken using cascade classifier, which is available in cascade classifiers for every features, right? For eyes, nose. Okay, it has got several hundreds of positive samples for a particular image. So this word is cascade classifier. And how are we going to use it? Okay, and it will be able to find, you would have seen some images, right, when you detect it, whether you want to focus on to it, right? And here I'm using yeah, here I'm taking the same thing only, the CB2 and the NumPy. Face cascade, I'm using har cascade frontal face default XML. Okay, this is an XML file. I can show to you. This is the frontal face. Okay, only the face. If I want to segment it accordingly, whatever you need, you'll be able to. This is an XML file. Okay, this is the hair XML file. Okay, and it is all given to you. So I'm using my eyes and my face to this variable, face cascade and eye cascade. I'm using an image called test3. Okay, test3 is this image, and I'm making the image to be a grayscale image. All right, and then from blue green to, I'm just showing my image. Okay, image 11. Well, this is my image. Okay, and this is my family, my father, my mother, my husband, myself. Okay, and my kids. It has taken long years before, but my daughter has now crossed my height. All right, and my son is to my shoulder. Okay, so I'm just showing the image here. Okay, image, I've taken it, I've read that image. I'm just showing that image. Okay, this is the grayscale of that image. I'm going to use face cascade or detect multi scales. Okay, how many scales I need? So it's totally 6. I'm giving the 6 number of faces I want to print is 6. All right, so I'm using cb2 dot rectangle. What rectangle I need to have? Okay, can you see 1, 2, 3, 4, 5? Rather, my father's face is not being captured. The reason behind, this is an image, and the image of a shirt blends out with this background image. Okay, so then you need to optimize your algorithm to find it out. Able to find how it has been segmented? Able to find? Using only face detection, we have done it for it. Able to find? Like that, for images, you'll be able to find it out what you need to do it. Okay, if you have a deceased image, according to the deceased image, you can take it. And also you can image segmentations. You can also have like RCNN algorithm, right? For image, how do you want to segment? Like you can have IDs. Okay, if you want to segment a person, bicycle, or so many things. Okay, this is an image. Okay, this is an image. Okay, test image I've taken. So can you see bicycle, people? All right, see, can you compare to this? I've given index like toothbrush, hair dryer, so many things I've given, cell phone, apples. Okay, so each image has been mapped on to an ID. Each image is mapped on to an ID. and then I'm loading that image path. Okay, whenever an image is taken it and it is loaded, the type of the data converts to be a numpy array. So the np array f dot read of, I'm using image dot open onto the image path, the width, the height of the image. All right, this is the image all about. Okay, I want to segment this image. Okay, so I'm using a TensorFlow session. Okay, the TPUs that I want to run it. I have a pre-trained model. When you come into Keras or TensorFlow, you have a pre-trained model. Okay, using the saved model, I'm going for instant segmentation and retrieving the prediction, whether number of boxes detected, how many box. First I'm initializing it to 0, then according to the detections it finds out and it visualizes it maximum to drawn, maximum score threshold. Can you see after the algorithm is run? Okay, are you able to see the segmented part of it? See, it's umbrella, it's person, it's umbrella. Initially we gave some IDs, right? You remember? We gave some IDs. Accordingly, the image has been segmented. It is using mask or CNN. Using mask or CNN. Okay. Only when you sometimes it may look little different, but once only we started working on with that, you'll be able to do it. Okay. Okay, what are the packages we have seen? Yes, please. For image, in this afternoon session, what are the things that we have seen? Can one of you recap? Can,
Canny.
yeah, canny edge detection. You have seen about canny edge detection. Yeah, and then the
threshold find counters.
Yes. Then yes, please. We started the session with thresholding, the different 5 thresholds, and then how these thresholdings could be done. And then we started with finding out within CV2 on canny edge. It is actually a multi-staged algorithm. Okay, it's actually a multi-staged algorithm. All right, and then we were trying to find it out how it could be. What are the stages? Anyone remembers? What are the stages on canny edge? First, you need to convert it into a grayscale. Then you went in for finding, reducing the noises. Then the image gradient is we are going to find it out. Then hysteresis thresholding. Then in canny edge, you are able to find the entire threshold, entire edges of an image, right? We are going to find the entire edges of an image. So that is what, and it returns how far, what are the steps that we are going to do, the minimum threshold, the maximum threshold, what is it returning, right? So those things we have seen. And then we moved on into, after canny edge, what did we move on into? We moved on into find contours. You remember what does contour does? It finds only for the closed images. It only finds for the closed images. And what are the pre-processing step that we need to do? We have learned a lot of filtering mechanism, thresholding mechanism, augmenting mechanism. You want to blur it, median filtering. So it does it. And then we showed you an example of watershed algorithm where it was able to segment the tumor present on the MRI. Yes. Then we moved on to using hair cascade, using cascade classifiers. It is a predefined frontal face recognition. Once your image is sent into it, and you'll be able to figure it out. And also, at last we saw about mask or CNN for different objects, how it was able to detect it and have a box over it. All right. Hope this 3-day session would have been useful, right? And as they said, I'll just give a review of my organization. This is called Computation Intelligence Research Foundation. Okay, we have established in the year 2017. All right, and it's a Section 8 company. All right, and The main vision is to to contribute nation building through mentoring and innovation. I strongly encourage faculty members, because the HEI, yes, the higher education institution, are given a lot of chances to have startups during the college time, and you have got plentiful resources. Your students are your resources. Okay, train the students once you are trained, through which your students could be trained. Try to build so many startups. Okay, it would be beneficial for the organization, for you personally, and also for the students, right? And we undertake product development activities in emerging thrust areas. We support higher education institution to establish innovation ecosystem. We introduce different courses, right? These subjects were not what you and me studied in our UG or PG and or PhD. Every day is a learning process. I strongly encourage faculties to learn every day. That's the most needed of that. And for industrial and societal demands, and we collaborate with institutions, research and development organization, and industry. We need to serve the community as a large. This is a mission of our company. And what is a goal? We train students, faculties, and corporates on latest technology, maybe in your breaks or in your semester breaks. If faculties, if you want to get yourself trained, I invite you to come to my company to have a 5 days full hands-on session training. That is what our company, because being into a college, being a professor in HR, I know what is the need gap analysis, right? What is that a faculty needs? So we have been successful. We have trained faculty members. They come, they stay between 10 to 4. They develop at the end of 5 years, 5 days, they develop projects, right? According to your own interest, what is that subject that you want to get? No theory, less 20% of theory, 80% will be hands-on. The reason behind, you can think why ma'am is asking us to come to your company, because when you are into an organization, even I had been there, you'll be calling, you need to go here and there, but once you step out and step in here, you will be able to focus the entire day with less distraction. And once you develop a project and develop something on your own, we guide you for paper publication or writing on using LaTeX tools. And you need to submit it to a journal, right? So on ACI journals like Q1, Q2, Q3 journals, right? And we collaborate with the institution to conduct value-added courses if there is a requirement, and to establish innovation ecosystem. And we provide summer and winter internship. Now internships are going on, and if you want really a student to get trained, we give as a course like semester 1, what do we teach during the semester 2, and semester 3 and semester 4. The students will be very clear. First we tell them what are the opportunities, then we train them on technology, and semester 2 on the particular technology they focus on to it. Semester 5 they are clear on what project or product they want to develop, and they keep developing it, because they come here so trained and they get 6 months of guidance, and by the final year they are ready to launch onto their project and going in for a prototype. We work with research projects. We are assisting for patent drafting and filing, assisting to set up startups, placement assistance, and counseling for career guidance. Okay, if any of these things are maybe useful to you, you can contact me. Okay, I hope. Okay, now I'll just share a link. Some of you would be into it, right? We are going to play a live quiz. Okay. Okay, have you got the link on the chat? Just give your name and log in. Just give your name and log in. 2 of you have logged in. What about others? 30 of you are present. Give your name and log in soon. I hope these 3-day session, those who have clearly listened to it and worked on, would have been useful. I know some of you have got preoccupations. The entire content has been recorded by SAIRAM Engineering College Department of IT. They will share it with you. Try to practice it. In addition, it is also on my YouTube channel. Kindly subscribe. Kindly subscribe to the channel. If you find the session was useful, you can give it on to the comments. All right. And you can share the link for the people who are in need. Okay, Don't think it's only session getting certificates. I think certificate is just a paper or a e-file, but how much knowledge you're going to acquire is more important for faculty members, right? Yeah, during this time, a lot of faculty members, they keep running for certificates, yes, but at the end of it, how far it is useful, how far you're making it reproduce to your students for the beneficial of the society. All right. And yeah, only five of you, I don't know, on eight of you have joined. Let's start out of 30. It's up to you. All right. So let's start with the very first question. Let's see whether deep learning is machine learning. Whether deep learning is machine learning. Yes, the answer is yes. I told you, right? On day one, we have an artificial intelligence. The subset of artificial intelligence is machine learning. The subset of machine learning is deep learning. So, mandatorily, deep learning is machine learning. Let's see who's the winner in the first round. Gomati ma'am is the fastest, and then second is Deepa ma'am and Joshua sir. Cornelius, right? Cornelius Joshua. Let's see what's the second question. We move on to the second question for the day. Let's see. PIL stands for, you may remember in the morning session, it is Python inbuilt library or Python incorporated license or Python emerging library. All of you have given the right answer. It's Python emerging library. Well done. Let's see who's the fastest. Yeah, two of you are fast, Cornelius sir and Deepa ma'am. And let's see. And third is Gomati ma'am. Let's move on to the third question for the day. Which model identifies to which an object belongs to? Whether it is classification or clustering or regression. Which model identifies its classification model or clustering model, regression model, to which category an object belongs to? You remember on the first day we saw about classification, clustering, and regression. Well done, 6 of you have given the right answer. Out of 30, only 8 have joined, and out of it, 6 of you have given the right answer. It is classification. Who has answered faster and still who's on the first position? Let's see. Yeah, so Ruchi ma'am, you're the fastest in this round, but the first place is Deepa ma'am, second is Gomati ma'am, and third is Cornelia sir. Let's move on to the fourth question. Which data set has a label? You remember first day we are seeing whether it's a labeled data, whether it is supervised or unsupervised learning. Which learning contains a labeled data? With an example also we have seen. Remember the apple example, the apple, bananas, and the mangoes example for both supervised and unsupervised, which contains a labeled data. Oh my God, everybody, you have given the right answer, and the answer is supervised learning. Shanti ma'am, you are the fastest. Still on the first place is Deepa ma'am, go second place Gomati ma'am, and third place Cornelius sir. The final question. That is going to define who's the winner of this workshop. All right, all ready, set, go. After that, the winner could unmute their mic and share when the time is given to you for the winner. Which package is used to interpret images and videos? Is it pandas or computer vision or NumPy? 3, 2, and 1. It's computer vision. What is computer vision? It is a CV. We've been practicing right from yesterday. Pandas for image processing. NumPy is only a dimensional array. When you take the image, it comes to be a NumPy. Okay, but the package is computer vision. That is CV, CV2. Let's see who is the winner. Let's see who's the winner. Yeah, Deepa ma'am. None other than she was the active participant for all the 3 days and she has been continuously updating. Congratulations, Deepa ma'am and Shanti ma'am in the second place. All right. And how was these 3 days hands-on session for you? You can post it. You can multiple time also. You can post it. Okay. What are the new things that you have learned? How far it is useful for you? Hard work always pays. Deepa ma'am was consistently doing it. Very good. It's anonymous. You can keep typing out. I don't get any of your names. What is your feedback? Like several times also, you can like 5 to 6 times. I've got some answers about data analytics and NumPy. It was very useful. Thank you. What about others? Very useful hands-on session. Okay. The session, thanks to Doreen Robin ma'am for the training. Thank you. Okay. So what will you please give the contact details for further classes? Sure, I will share my details with you. Excellent session. Thank you, Cornelius, sir. It's glory. Your fluency is good and jovial interaction. Thank you so much. Okay, so on these 5 days, on these 3 days, we started with what is analytics, all right, and then we started with the different types of analytics, and then where most importantly, the different, what do I say, the different, where you need to use classification, where you need to use regression, and wherein you need to use your clustering mechanisms. We saw about labeled data, unlabeled data. Then we were trying to work with kidney data and our data sets. It's a benchmark data set. We have taken it, all right. And then from which we started working with what did we say? We started working with kidney data sets, and then we had worked what are the different visualization using Matplotlib, Seaborn, and Plotly. All right, and then we moved on into from the visualization, we were able to find some columns should have been integers, it was objects, then we converted it. We used label encoder to convert um, text data into categorical data into numeric data. Then once everything is set fine without missing numbers, then we started working with machine learning algorithm. Yesterday we worked with three or four algorithms, I guess, and different performance metrics. And then today we saw if once it is developed, we can make it as a prototype or a usable product. Okay, for when you give it to an end customer. So there are so many problem definitions that still you need to address in your own universities or colleges or companies that you work. Okay, you can see and you can start working on with that. And then we moved on from today, we moved on into the image analytics. All right, in image analytics, the different packages, SK image. All right, and then we moved on into SkyPy, and then we moved into OpenPill, and then OpenCV. Okay, pill and OpenCV. All right, and then we moved on into how to take a data set and how to work on with that. For each of the packages, we have used different what do I say, for each of the packages we have used different manipulations. And then after session we were saying about canny edge and also the edge detection algorithms. All right, and then we moved on into face detection and segmentation, and we have taken an image data set. Okay, I hope, yeah, very good, you're all giving very useful program. It's wonderful. Yeah, my email ID is doreenhm@gmail.com. You can send your mails, and my contact number 900302135. And kindly subscribe to my YouTube channel. All my events I post it onto my YouTube so that it will be useful for people, or you, even this 3 days program is being uploaded, you can feel free to share. But most important, learning, we need to teach it for others, we need to share it, we cannot keep it for ourselves. That's what I think, that's more important in education field, so that students also will be students or anybody, the co-teachers will be able to use it, right? Thank you all. God bless. Over to the organizers.
Thank you, ma'am, for your valuable insights. This hands-on session gave us a real-time experience and it was very informative. Now, the word of thanks will be given by Mrs. Sharada, Sri SAIRAM Engineering College.
Good evening, ma'am. Good evening, everyone.
Good evening, ma'am.
Dear all. Dear all, first of all, I wish to thank our management, our principal, our dean, and our beloved HOD for giving us the great opportunity. Thank you very much. And my sincere and thanks to our data scientist, keynote speaker, director of CIRF, your excellent coverage of data analytics, ma'am, using Python language, the various libraries, and you have wonderfully demonstrated all these concepts using Colab. It's really fantastic, really interesting for us. Then it's very cool to execute all these things. But I believe that participants have enjoyed this session and have they've gained much. Yes, ma'am. Thank you, ma'am. We are all really inspired with your presentation. And I'm very grateful to our participants for promptly joining and attending the session for the past 3 days. Thank you, participants. Thank you all. And finally, I wish to thank our program coordinators, Dr. Adlin Matrika, and our Professor Saranya and Ms. Aarti for their wonderful support for successfully executing this program. Thank you one and all for present here. Thank you very much, madam.
Welcome, ma'am.
So finally, we have reached the end of this 3 days virtual faculty development program on predictive healthcare analysis. I would like to thank everyone who contributed to the success of the event. Thank you, ma'am, and thank you all. Now, the feedback link will be shared in the chat box. I request the participants to complete the feedback procedure. After completion of the feedback procedure, the participants can leave the meeting. Thank you, ma'am, and thank you all.
Thank you.
I request all the participants to switch on their video for the photo session.
Yes, everyone, please do switch on. This would be the memories that you could carry. I could see Ramya ma'am, Sasi Kumar sir, Deepa ma'am. Yeah, Suji, Priya ma'am, Cornelius sir, Panjavarnam ma'am. You had been hearing your voices for long. Others? All have a bright smile so that they could take a picture. Yes, 1, 2, and 3. Thank you. I've taken it. I will share it, and even the organizers would have taken it, I suppose.
Thank you so much.
Okay.
Thank you, ma'am. Thank you, ma'am.
Thank you. Thank you all.
Thank you, ma'am.
Thank you. Bye-bye. We'll all meet soon.